All righty. Hey out there. Welcome to this week's Cribl weekly demo, replacing your Syslog server with Cribl LogStream. So before we jump in, just wanted to take the time to introduce myself to those of you that I haven't met. I'm Desi Gavis-Hewson, and I'm the Senior Solutions Marketing Manager here at Cribl. Previously, I led the national sales team at a co-working company called Industrious. And before that, I was on the sales team at an ad sales enablement company called Media Radar, and I built the sales development team at Trello. So my path to Cribl is a little non-traditional for sure. I've been in a few different industries in my career. Ultimately, though, it was a no-brainer for me to come to Cribl. I just really enjoy matching people and teams with tools that give them more flexibility and choice in their business. And ultimately, that's what our flagship product, Cribl LogStream, provides. So great to meet you. Here's what to expect on today's call. Let's get into it. So almost every week, we'll be doing a full demo of Cribl LogStream and walking through specific use cases in the product. First, I'll do a quick introduction to observability pipelines and LogStream for those of you who may not be as familiar with us or what we do. From there, we'll move into a full demo of LogStream. We'll talk through the specific use case for that week after that. Obviously, this week, that's going to be replacing your Syslog server with LogStream and the volume reduction you can get by doing that. And then you'll have the opportunity to ask any questions you have regarding Cribl, LogStream, or anything you've heard or seen today after that. Global data is growing at a 25% compounded annual growth rate. And I think everyone in the world understands this to a degree. So if you take being in a global pandemic, for example, rather than our business meetings happening in person, they're happening on Zoom, and Zoom's generating data, right? So even if you think about it from a non-technical perspective, it's easy to see data is growing astronomically. By 2025, enterprises will be managing 250% more data than they were just last year in 2020. So the amount is growing, but there's another problem. Logging systems are already at capacity. I hear from enterprises daily with costs in the millions when it comes to licensing, and the infrastructure required to store that growing set of data can cost as much or even more than commercial licensing costs. More data also means you need more CPU dedicated to analyzing it. And for many customers, the added infrastructure costs can be in the tens of millions of dollars. On top of all that, you get inadequate data retention in some organizations. So when your logging system is reaching its limits, many people believe they have no choice when it comes to dropping data that they like to keep around. To get the answers you need out of your environment, you have to onboard new sources of data. There's no way around that. Most companies drop large portions of high volume sources because it's too cumbersome and costly to analyze everything. You might also have retention policies in place to meet certain standards and regulations, but you're having to guess, right? How long can I afford to keep this wider set of data around? And you may need to revisit that data later, especially if you're investigating a security breach or trying to understand long-term trends in your IT environment. So for some use cases, they may need to keep data on hand for years, and that data needs to be ready for analysis the entire time. Lastly, systems are optimized to handle data analysis and retention separately. So what that means is you often end up using many different tools to retain and analyze all of your machine data. And adding each one of those tools also adds complexity and hidden costs. So like I mentioned before, environments are getting super complex. You have your object storage, your time series databases, your data lake houses, just to name a few. And each of those have their own agents and their own ingestion pipelines. It gets really tough to manage it all, and it forces enterprises to make some hard choices about which data they want to send to where. And those choices usually being trade-offs, right? You end up playing this three-way tug of war with cost, flexibility, and visibility. I mean, the more data you analyze and the longer you retain it, the more it's going to cost you. If you standardize on a single tool or try to do that, that's going to limit your flexibility. And if you drop data to keep costs down, that could limit what you can learn or investigate over time. So how do you do it, right? How do you manage the trade-offs of analyzing everything you need to get insights from your machine data, formatted for all the tools you use without busting your budget? Well, an observability pipeline solves all of these problems, and our product, Cribl LogStream, helps teams implement an observability pipeline without replacing any existing tooling. LogStream enables customers to choose what data they want to keep, in what format, and in which data store, all while providing that assurance, right, that they can also choose to delay any or all of those decisions with a full fidelity copy and low-cost storage. LogStream is going to provide our customers with a vendor-agnostic solution to route data to and from any tooling source or destination. So regardless of which tools are in use, because we're vendor agnostic, right, LogStream can centralize the forwarding of all machine data, get it to the right destination, and ensure that it's shaped, enriched with whatever information you need, and ready for analysis, or simply on standby, right, for when you might need that data in the future. Last thing here, Cribl LogStream significantly decreases an organization's logging and monitoring costs, saving customers about 30% of infrastructure costs on average. So one question that might be popping up for you is, DESI, doesn't data streaming already exist, right? Isn't this just Kafka? No, it's not. Data streaming does already exist, but the data streaming solutions that do exist are not purpose-built for polystructured data. On the other hand, an observability pipeline, which is what Cribl LogStream helps put in place, is purpose-built to work with even the most complicated data formats. So the data you need probably exists in multiple sources with different protocols that dictate how that data is generated and collected. You've likely got data coming in a variety of formats, and those formats may not always match the ones required by the tools you use. And you've probably also come across streaming solutions that just couldn't scale with your business requirements. Cribl LogStream can. We've tested it at over 20 petabytes of data a day. So if you remember nothing else I've said today, remember this. Cribl helps implement an observability pipeline to route security and machine data where it has the most value. We're going to help you slash costs, improve performance, and get the right data where it's needed in the formats required. With Cribl LogStream, you can reshape, reduce, or route data so that you remain compliant and get the insights you need in the most cost-effective way possible. So next, I want you to see the product. My colleague, Mo Hassan, who's actually on the line from our solutions engineering team, has graciously recorded a full walkthrough of some of the key use cases of LogStream. So let's take a look at that now.
Hope to do is going to do introduction, no discovery, obviously, and then we'll discuss the highlight of the product and the architecture and maybe hands-on demo. Those are the logos that we come support out of the box. So Cribl LogStream, as you might know, is an inline processing engine. It sits between your sources and your destination. And whether you're dealing with cloud services, you're dealing with push-based, pull-based sources, Splunk, Elastic Beads, Splunk Signal Effects, FluentD. I mean, you can see the bunch of logos here. We also do several file formats, all the file formats under the sun, XML, JSON, CSV. We can do translation. And we accept raw TCP. So we'll cover that more in details. I just want to go over quickly overview of the product here. Question keep coming up all the time. What is Cribl LogStream? Simply put, it is a layer sits between your sources, and this is only showing 3 sources, but we support a lot more than that, and your destinations. So and we do the processing in the ingestion pipeline itself. And when I say processing, we're talking about redaction, encryption, routing, and we'll cover more of those details in a second here. Here's a little bit more deeper view of the architecture. Basically, on the left, you have the sources. And again, as you've seen earlier from the previous screen, we do a lot of support for multiple sources, and namely the big ones, Splunk and Elasticsearch. And not only that, we accept Syslog, we can pull data from Kafka, from S3, from Amazon SQS, Kinesis, Microsoft. I mean, the list goes on and on and on. The data get ingested into Cribl LogStream, and the reason I have this slide here so we can help you understand when we go to the demo. We have concepts called routes and pipelines. Every route has at least one pipeline attached to it. When you hear the word route, think of the filter. If route is a way to pinpoint the data coming to the product on the stream side, on the ingestion side. The pipeline is how do we handle this data? What do we do with it? How do we reshape it? And obviously the destinations are inverse of the previous of the sources. Again, it's just the same thing here, but this slide here is breaking down the architecture, but saying basically we have worker nodes, and those can be grouped together. You know what I mean? And then they're all talking to a master node. Master node does not do any data processing. Basically, it coordinates the cluster behavior, if you will, share bundle data, that kind of stuff. One of the things that I like to highlight to the product, and it's we have something called persisting queues, where if your data in the left here is if your destination's down for some reason, your Splunk infrastructure cannot be reached or down for maintenance or whatever, we have the feature called persistent queues, where you can actually let LogStream store data temporarily until your infrastructure or your login solution comes up again. We have built-in regex editor, and we have revision control, which is GitHub support out of the product. The concept of worker groups, as I said earlier, the worker nodes where the processing is happening can be grouped together. And why would you want to group those together? An example here is if you have multiple providers of cloud providers like Microsoft or Amazon. So as you guys know, the providers will charge you for egress charges. So pushing or installing the worker nodes or worker groups closer to the sources in the cloud. So this way, all the reduction and the compression happens before it reach your on-prem or anywhere else. So this way, when the data leaves your cloud instance, it's actually reduced, and therefore you're reducing the ingestion charges. The other common use case, if you have remote offices and let's say you have a smaller office somewhere with a weaker link, and you're doing a lot of Splunk maybe or Elastic sources coming out from that smaller office, and having worker node closer to on the small office itself can actually reduce your footprint on the link and the stress. Those are two major use cases for grouping worker groups together. The major feature, which is a discussion here today, a topic of discussion, is actually the replay feature or data collector. As you've seen before, data comes in from the left and it gets processed in events. One of the things you can do to the data stream is actually archive it, or you can just process it with a bunch of functions that we're going to discover later. So archiving can happen to S3 buckets or any S3 compliant like MinIO. It can happen to through a REST API. It can happen through an FS mount, or you can write your own script if you wanted to. So imagine this thing: data comes in, and I'm going to split the stream. One goes to Splunk. The other one goes to my S3, which is really cheap storage. So you can keep the data in Splunk for a week, 30 days, whatever retention policy, but then you have continuous recording, infinite if you wanted to. The use case we talk about here, a customer with, I think, 10 terabytes or something like that, and they were able to save $1.3 million by utilizing very, very cheap, long-term, 1-year retention on S3. And once you really need the data, and this is for security investigation, obviously, or other things, but security investigation seems to be a common use case here. But if, let's say you want to get the data that's a year ago, all you have to do, go to the UI in Cribl LogStream and re-ingest that portion of the data into your login solution. So you basically have your cake and eat it too. You have your immediate data available for quick searches in your login solution. Yet, if you want to keep high volume, low value, like NetFlow, for example, and you can actually store that in S3. A lot of my customers actually will have continuous recording, split the stream to S3, because S3 is really dirt cheap. It's extremely cheap, and there's no reason not to be able to utilize that feature. We'll cover that in the UI in a second here. Examples, again, if you're existing a LogStream user, you're probably familiar with those, but if you're new, I just want to highlight what can we do with the product. We can do, this is the reshaping of the data I was talking about. We can do reduction, we can aggregate. We actually act on events and on source types or metadata like source type or host name or IP address. So things we can do is aggregate the data. We can drop the event completely. We can sample the events. We can do dynamic sampling. We can change logs to metrics. And, the advantage is obvious there. We can suppress the events if you wanted to. And the archiving and the actual tangible dollar where you can actually measure it is if you can actually route data to multiple destinations. So let's say you're using Splunk today, tomorrow you're going to use something else. You want to investigate different logging solution, you can easily do the migration with the routing feature. Again, as I said earlier, it's not just S3, it can go to a regular FS file-mounted system. We also enrich data inline. We can do CSV lookups or GUIP or DNS, just regular lookup stuff. People might ask, why would I want to do a lookup on inline versus data at rest when it hits Splunk or Elasticsearch? There is an advantage to that, especially when doing security investigation. Let's say you're mapping IPs to host names. You really want to do that mapping at the time of incident, time of ingestion, not a day or a week later. In a DHCP scenario, or sometimes the host and DNS names and IPs are fastly changing, and so it's critical that you actually map them together when it happens. The same thing happens for logged in user to a system. So there's an advantage of doing lookup at the time of incident versus hours or days later. There's some security functions also. We can encrypt fields and we can mask fields. Again, it can be done in the login solution, obviously, but doing it in the stream, you're actually guaranteeing that nobody, by the time the data gets to Splunk or Elasticsearch or Kafka, whatever it is, it's already encrypted. So there's no room for tampering. Formatting, and that's where we get the concept of what we call ourselves universal or a schema agnostic. Imagine this thing, it doesn't really matter where's data coming from. So you can have universal folders, Splunk universal folders in the raw format, and they can change the data to Elastic Common Schema, which is JSON, and then from your UF you send it to Elastic, or vice versa. You can have Elastic beats with JSON formats and send it back to Splunk. We do the reformatting in the process. We can flatten the data. We can translate the data from CSV to JSON back and forth. You can reserialize the data. I mean, there's a bunch of other functions that if you're a regular customer of the product, you're familiar with. But this is really the power of LogStream. It's just the fact to give you great control over what you can do with your events before they get to your login solution. Okay, we've covered that. Let's get to the demo. And I'm going to focus. Here's a demo. When you first log into LogStream, you'll see this screen. So you keep track of time. Obviously, we have sandboxes. You can I recommend that you haven't played with it. Just go ahead and it's a guided tutorial. You can just spend 45 minutes, an hour. It will tell you how to do reduction, how to do enrichment, that kind of stuff. So we also have a bunch of blogs, bunch of videos. So there's no shortage of information. Trying to learn the product. One of the things you can do when you log into LogStream is to get in the monitoring console or the monitoring screen, if you will, here. Basically, it gives you statistics and aggregation of what's happening, how many events per second, how much data in, how much data out, and then a bunch of information about your host, basically the health of the host. It's good for troubleshooting. Not only just aggregate view, you can actually drill down by sources. So I can look at my sources here. I can tell you this particular source is kind of working, this one barely working, this one is very jaggedy, and then again, the in and out, and the same thing can happen for destination. Also, if you're familiar with the product, you've heard the term routes and pipelines, and so there's another way to get an insight how much data being processed, APS, and total data in and out. Again, great for troubleshooting. So how do we, so in this particular environment here, we have multiple worker groups defined, and we have one called logs here. So when you first go to the worker node, again, you see tabs on the top here, and data, and the defined destination sources and the collection feature which is replay, or you can define your routes again, filters. How do I zoom into my data coming into the pipe, and then pipelines, which is how do I process this data. Example of simple use case. This particular one here, it's data called trim big JSON. By the way, these things can be moved up and down if you want to change the logic. So I have a one called archival here, because this is really the focus of the discussion today. Archival is saying when the data comes in and route name is archival, filter is true, which is mean I want to apply this logic to all the data, all the streams, everything. And then pipeline is pass through, which means do not do anything to it. And then output is going to be S3. And by the way, it doesn't have to be S3. It can be, can be any other destination or anything that you defined in terms of destination. So let's focus on the enrichment use case. Trim big JSON is one route name, and this attached to this pipeline or the output, if you will. If I click on it, and it's going to send me to this tab, the pipeline tab, and expanding. Obviously, everything would have a comment. If I expand the tab to see what am I doing here, basically I'm zooming into a source type called Lambda, and then I'm applying a function called serialize. The functions that we have at your disposal coming from here, and as I said earlier, you can do aggregation, sampling, dynamic sampling, and masking, all the good stuff that we mentioned earlier. One cool feature about this product is now I have my pipeline defined, if you will. I can sit here and say capture view, and it's going to use this filter expression. By the way, we use Java expressions, JavaScript expressions. And if I do capture and ask me, you want the first 10 seconds or first 10 events, either way, it doesn't really matter. And the system will actually start, it's like sniffing, if you will, and capturing data coming in as it comes into the stream. And there we go, this data comes in. And if I look at my data here, I can tell you that this one header here and multi-value headers, those are duplicate of each other. And my task here is to remove one of them. So I can save this data, and I have it now. And here's the pipe. Here's the data the way it came in, that I captured, and here's what happened to it. Look at in and out. Here's what happened to it when I actually applied my pipe to it. And in this case, I did some reduction. And if you can see, multi-value headers grayed out because I said 20 items here, headers 20 items were duplicate of each other, and what we did here in the left says we dropped field to remove. We're going to drop this multi-value header, which is this guy here. The impact of this change is actually as 44% reduction in your data volume. Obviously, the developer of this code decided to duplicate the data for some reason. So, and there's so many tricks and things you can do like that. If you look at the data, I mean, simple syslog, and if you can remove a few bytes from an event and you have high volume of this data, you're talking about gigs and gigs. If you have 10 terabytes, and I can save 5% of this particular file, this particular source, that's significant. Again, operational mode can be serialized, it can be extract, and JSON, or the type of the file that we're dealing with here can be CSV, extended file log format, key value pair. Those are the formats we understand out of the box, if you will. There's something else we can do here. This one here, filter expressions. Basically, we're saying here anything with value null, I also want to drop it. And that's one example of how you can do a reduction of data. Let's talk about a enrichment of data. Pipeline, or the routes called firewall Palo Alto. Again, it's just basically what it's doing here is source type. I'm just focusing on the first source type to pinpoint the data. By the way, the routes here get sequential execution. So it starts from the top, we go to the next one, 3 and 4 and 5. If you want to stop that execution, all you have to do is just toggle this thing, it says final, yes or no. If it's set to yes, it will not go to the next step, and it will actually exit. Basically, it's like a break statement in a loop, if you will. This is my route called the Palo Alto Firewall, and this is the pipe attached to it. If I click on that, let me just collapse this. If I click on that one, as I said, showed you earlier, we can do capture, or we can actually use a sample file that's already been captured, or you can actually manually import or cut and paste if you wanted to. So looking at my sample input from Palo Alto or PAN traffic data, this is the data, and this is what happened to it after it leaves. What we're doing here is actually, first we do the reduction, the extraction. So we did a bunch of functions here, and basically, since this data is, if you can see field, comma, field, comma, field, comma, there's no, it's not key value pair. So you have to know the schema ahead of time for this particular file type. In this case, it's published. I mean, you can find it from Splunk, you can find it from Elastic configuration, you can find it from the vendor itself. So I know the fields, and I'm going to apply this schema, if you will, to those fields. Now they're being extracted for me. So now they extracted the field, things I can do GUIP lookup. Let me collapse this thing so it's easier to read. I can do GUIP lookup. So what I did here, anything with source underscore IP and destination underscore IP, we are going to apply GUIP data, and it's going to be, we're going to add a field called source underscore GUIP. And if you look at my data here, see those fields here, those are added fields. Basically a GUIP data, city, country, latitude, longitude, all that stuff. So this one way of enriched data, this is actually not reducing data, it's actually enriching data. So you're adding more to the size, but again, it's an option for you if you want to enrich data in stream. The enrichment doesn't happen only on lookup or GUIP. You can do it against regular DNS. So in this case, source IPs, and I translate them to this field name here. So, okay, so source underscore IP, source host name, or I can do the same thing with destination, actually. Yeah, so here's the source IP, and here's the destination host name that I was able to look up on the fly from a lookup table. Again, the same thing applies to the other IP. The lookups also can happen against CSV files, and we do support site annotation if you have your network segmented and non-standard ABCD, you know, like /30, 31, you know, 29, things like that. We can actually support that too out of the box. And in this case, we are zooming on source IP or location, and we're able to pinpoint the IP based on or lookup file, and just simply says, yeah, this particular IP coming from HomeNet. Let's see if I have an example here. Yeah, there we go. So this is a source IP 192.168 and subnet usage, or this is based on my data and my lookup file. I was able to say this guy is coming from his home. So because I call it home worker net. Those are the two examples of the enrichment and reduction of data. Another one quickly here that seems to be very common, masking data, sensitive data. And I have an example of the sensitive data file, if you will, and then data in, and this is what happened to it when it's really redacted or encrypted. I have to actually go to the, and go sensitive data. Where is my sensitive data? There we go, there it is. And this data in, and here's what happened to it when it came out. If I look at the function that was added, again, I remember there was a bunch of functions here you can pick up from, and masking and encryption is one of them. This is, I want to show you the regex editor basically built in. So what I did here, you can actually add your regex here. If I do the editor here, and here's my sample event, and this is the regex to detect the social security number. And this is the Java expression, replacement expression that I did. And it shows you on the fly, this is my social security before, and that's how it looks like after it's been MD5 hashed. Again, it doesn't have to be MD5, it can be encryption too. That is a simple, and here's a crypt function that we apply in versus mask, so be aware of that. We also support, every time you do a change, we have built-in GitHub, or you have to install GitHub in your environment, or you can use your existing Git repository if you wanted to. Okay, so that concludes the discussion for the product overview, and thank you.
Amazing. Okay, so you just saw a few general use cases of Cribl LogStream. Hopefully that's got some gears turning for you around how LogStream can help you optimize your data. Let's get a little more specific. So when ingesting data from Syslog senders, and Mo touched on this in his overview just now, Cribl LogStream can easily trim that data volume, right, by 30% or more, we typically see. And what that's going to do is it's going to optimize your infrastructure for any downstream services. We're talking, Splunk or Elasticsearch, whatever you're using in your organization. It's really going to help you see reduction there when you replace that Syslog server with Cribl LogStream. So now I'll turn it over to my colleague, Mo, who's actually on the line to walk you through how to do this. Mo, do you want to maybe introduce yourself before you jump in?
Sure. My name is Mo Hassan, and actually I look a little different than the previous recording. I shaved my head, basically. Yeah, I'm Mo Hassan. I'm a sales staff solution engineer with Cribl. I've been with the company for maybe 3 months now. Worked for Splunk for 5 years, and I was a Splunk admin for previous 5 years before that. So been quite a bit around Splunk and login solutions. Today, we will discuss a specific function of the product, and I'm going to share some screen with you, which is the ability to replace your syslog with LogStream. LogStream is 100% replacement for syslog. And let me share just one slide. I don't like really sharing too many slides here, but just one slide kind of show one slide that may possibly be something similar to your environment. This is a big environment, some real customer actually, with names are being removed. But this customer has a global data center, and they have a bunch of data centers across the world, and they have multiple Splunk installations and multiple indexers everywhere. But they also have a syslog implementation around each major Splunk installation. So each, like the NALA or North America, South Latin America, they have a bunch of indexers, and then they have 2 syslogs for it. The same thing for London data center and APAC data center. And this is the initial customer installation, if you will. So imagine the fact that you are able to reduce, we have about 6 syslog boxes there that you can potentially remove and replace them with our product. Our product has a bunch of use cases, as you guys know, but one of the side benefit is actually ability to replace hardware. So one of the cost reduction that potentially can come with the product. There's a bunch of other things too. We talk about sometimes about the ability to the fact we're doing regexing and all of the event processing and reformatting outside Splunk or Elasticsearch. We actually reducing the dependency, and enhancing the performance of your Splunk or Elasticsearch infrastructure. The fact you offloaded this functionality outside your repository, now it's done inline, that you should expect some performance enhancement and searching enhancement. And on top of that, then you can also replace your syslog boxes with LogStream. Let me stop that and stop the sharing and go to a different screen. When we said earlier that we are 100% replacement, so how do you do that basically? If you're familiar with the product, you know there's you can define your sources and destination. As I said earlier, we have a bunch of logos we support out of the box. If something that we don't have in front of you here, that's something we don't support natively, we also support script input. You can input things through a REST API, through a script, and a simple curl command can get your data in. And the same thing goes for the inverse side, which is the destination. So in this case, I want to configure my source, meaning I want to make LogStream behave as a syslog receiver. So remember with at least the major products, Elastic and Elasticsearch and Splunk and a bunch of other ones too, actually, they all recommend having a syslog box in front of their installation. That because of simple fact is those guys are not really designed to receive syslog data. They can through raw TCP, but that's not the main focus. Syslog is designed to be high volume. There's some reliability involved too. It's not, protocol itself does not lend itself to being reliable, but the way you handle the way you make your Syslog traffic reliable is by adding resources. And I've managed large Syslog installations around Syslog Engine. I'm very familiar with that. But here's how you do it with LogStream. Basically, you define a source. This is called Syslog, and through the UI, and we have a few of them defined here. One called, and you just do a unique identifier called input ID, and that applies to all sources and destinations. Anything else you configure in LogStream, any object basically must have a unique identifier or an ID. And then the regular stuff you define around Syslog is like what IP should I listen to, what port should I listen to. Again, remember I'm configuring LogStream here to be a Syslog receiver. So your Syslog, the sources can be your network gear, or Palo Alto gear, firewalls, whatever source that speaks Syslog protocol. They will also support encryption out of the box. So if you want to have encrypted traffic around Syslog, some people do, some don't. You would have to supply the certificates and the path and the passphrase and a bunch of other things comes around certification. We also can control the version of the certificate itself, the TLS version. So you have maximum and minimum in case you have multiple sources that speak in Syslog that work with multiple versions of TLS. So we can and you can see from version 1 to version 1.3 or version 3. Basically, some people call it 1.3, some people call it version 3. So just be aware of that fact that we support multiple versions of TLS. I believe this is a better Syslog than Syslog. Now, a lot of functionalities you see here can probably be replicated or with our Syslog or Syslog NG or any commercial solutions. The difference here, you have a UI. And you bind the product for other functionality, redaction, encryption, reducing data. That's probably what's driving the purchase, but it's really nice to have a side effect, which is replacing your hardware, your Syslog hardware. Things you can do, let's say you have a source, and I'm going to say Palo Alto here. Let's say it sends data directly to you in a Syslog format, but you really want to add a source type field to that data. So that's how you do it. You can actually ingest and add a metadata, if you will, change the host name if you want to. So you have the options to pre-process the data before it gets processed again in our engine, if you will. So it's nice to be able to tag things with source type maybe, or anything that Splunk understands or Elastic understands ahead of time. So you can say, yeah, this is a field name. I'm going to call it source type, and I'm going to just call it pan traffic if I wanted to. So by the time I get the event, now it's pre-source typed, if you will. We have something, if you remember from previous discussions, or if you've been around the product for a while, we have a pre-processing pipelines and post-processing pipelines, and then the actual pipeline where the actual manipulation happens. In the pre-processing pipelines, conditioning, if you will, in this case, we configured this to have a pipeline called conditions like conditioning. And if you click on it, it'll tell you it's just a regular pipeline, nothing really. And there are things you can do to the event itself, the Syslog event, ahead of time before it gets processed by LogStream. And in this case, we're saying here is, well, let's see, I would like to add index tag to the event. If it's there, leave it, preserve it. If not, call it Cribl index. That's the index name. The same thing. I like to add a source. If it's there, keep it. If not, just add app name to it. That kind of stuff. The app name, which can come from Syslog, especially with the latest RFC, not the older RFCs. And the same thing with source type. And then any other pipeline capabilities you've seen before in terms of functions and whatever the regular functions that you've seen before can be applied to the pre-processing pipeline. Just remember that it's pre-processing. You still have to apply your other pipelines afterwards, and it's just kind of nice to have feature ahead of time. Back to sources configuration. So the other things you can do actually, Just like a regular syslog engine, you can do a whitelisting, blacklisting. You can eliminate proxy if you wanted to, buffer size controls. As I said earlier, the only way, especially if you have a UDP-based protocol, or UDP-based syslog, TCP, it's not so much because there are more controls and with handshakes and acknowledgement, it's a little safer. But with UDP, the only way to handle drops is to add resources or control some values like the buffer size and the time zone and things like. Well, time zone is really just for convenience, but the buffer size is really critical. And what that means, the implication here is, and this has to actually correspond to your kernel configuration in your Linux box. So just because you set this here, you need to make sure that your kernel, I think it's syscontrol.ctl or something like that, the file, must really match that. But by default, Linux have a larger buffer size in the TCP, if you will, in the actual interface. But you also need to match that with what we have here. So the flip side here, just to be aware of, if the event is not timestamped, just like Splunk would do, we will timestamp it for you. If you have a large buffer size, this is saying I'm going to queue my events in memory, and then when I reach my buffer size, I'm going to flush them to disk. So if you have megs and gigs of memory allocated for buffer size, you can risk the issue of time skew. So just be aware of that, and that is a common problem with when people try to optimize syslog configuration. The other function here, by the way, this is a neat feature. If you get stuck and you're not really sure what this means, you just can click on help here. I'll give you instant help. What are all these configurations mean? So if I want to know what this option mean here, I can just say, oh yeah, let's see, what does it say here? Single message per UDP. And that actually gives you a description of what is this function can do. Basically, you're telling this LogStream how to handle multiple messages. Do you want to aggregate them together, or you just want to assume each message with a line feed carriage return is a separate message? And this applies to UDP, not TCP traffic. Keep check with time because I'm not really looking at the clock here. But again, metadata, as I said earlier here, I think mentioned that earlier, preprocessing is also a nice feature to have, be aware of that. Oh, and with the latest version, we can actually sit there and capture things as they come online. If we have any live data coming in, you don't have to run back and forth different screens. This is a new feature with 2.3, I think, I'm not sure, 2.3.2. But it's just a good shortcut, if you will, to look at the data coming in, instead of just flipping back and forth the screen. Okay. That's basically from the source side of things. From destination, again, this is the inverse. Now we are acting as a syslog source. Now that I configured myself as a LogStream, as a syslog receiver, I'm going to configure myself as a syslog sender, if you will. And let's see, where is syslog here? And if you add it, just like, and things to be aware of, again, unique ID, multiple protocols, TCP, UDP. You need to use TCP as much as possible, but just be aware some devices, some network devices, especially firewalls, high volume firewalls, may choke when it runs TCP, because TCP saying the other end should be up and running. If it's not, there's a lot of chatting, if you will, happens in case of failure. And with high volume firewalls or any generating traffic, any high volume machine that generates a lot of traffic, you're going to create a lot of noise. And some actually older Cisco devices used to have a bug where actually will crash if you do TCP. Not anymore. Most people stick with UDP, but again, if you do UDP, you need to also be aware of the scalability issue. And again, as I said earlier, the only way to be reliable with UDP is to add more resources, i.e. more nodes. Node ports, as you can have maybe 514 for the Cisco firewalls and 516 for Palo Alto and 1520 for something else. So this muxing feature, if you're multiplexing, if you're used to the old terminology here, that's also an option for you. So you can have multiple destinations and multiple sources and multiple configuration within the box itself. And then we have other things like around the facility and severity and other things that come standard and well defined in the RFC. This is nice. We actually support the older RFC and the new RFC, and I actually pulled up earlier a bunch of articles around RFCs just to see the difference, because I'm used to the old one, 3164. When I did some research on this one, it's just like they added a lot more fields around clarity, what each field should be, and they just added more definition to the statement, to the actual message itself or protocol itself. Back pressure behavior, again, what do I do if my receiving end was dead? So let's say your receiving end is I don't know, Splunk, whatever it is, or another syslog box. So we can act as a hub. You can actually, in a syslog world, you can actually have multiple hubs where the message move from one syslog engine to another, to another, to another. So think of us as another syslog engine in this hub path, if you will. So if you're my sending, my receiving end in the other side of LogStream is dead, I can utilize the existing features called persistent queue, which means store things locally. And again, similar to what Syslog would do, in this case, everything is done and driven by the UI. And then obviously the TLS settings that we talked about, again, I'm acting, as I said earlier, I'm acting as a client. I am the client right now. I am the sender right now. And then a bunch of timeouts and great feature if you will, in a high volume environment, you can have a great fine granular control over how do you want to handle your syslog traffic. So, questions so far? Okay, I can show you a use case where we're doing reduction, but of the using syslog traffic. But that's kind of if you guys remember the product, you kind of know. But I'll cover it quickly here. In this case, let's see, where is my? Let's see if I can just use my stuff. I'm going to look for a syslog file or syslog generated file. Pan. Even though this is really not what I'm trying to do today, is I'm just gonna try to highlight the fact that we can actually replace syslog, your syslog box, with LogStream. So I picked up my event file, and I'm gonna just pick up my Apollo. I don't have it. I don't think I have this particular. Oh, this is route, sorry. V4, regular traffic. And again, you've probably seen this demo before, but it's just it's a way to reduce your data, if you will, using Palo Alto. And go back to the sample file I have here. This is V4. I don't want V4. I want to look for it again. And without going into details, because we covered that actually quite a bit in the past. This is how the data looks in. By the way, just to look at, and I'm going to increase this quickly here, and keep the time check for me, please, because in case I'm not looking at the clock. But this is how, for example, a Palo Alto firewall send things in a syslog format. And I can tell this is the RFC 54, the latest one, I forgot what it was, 54 or 24 or something like that, or 25. So if beginning here from this is the actual message itself. This is what Palo Alto cares to deliver for you. Everything before that is just to be compliant with syslog. Okay, and this is a critical distinction here. They have to put this here because they want to be compliant. They match the protocol. That's what the protocol asks for. Things like this number, I forgot what this number stands for, but it's probably a combination of severity and log level or something like that. You can look it up. My point is, something like this, something like timestamp that comes from syslog, that also you have an event timestamp, look, and then the host name. I mean, you actually can tell right away the app name. You can tell right away, I do not need this data segment. Again, in a high volume traffic, Palo Alto, just removing this few bytes here will actually translate to a significant reduction especially like 230 terabytes a day. And if you notice here, the extracted field, the app name, the facility name, facility, these are all, the host name, these are all part of the standard RFC that we followed. Therefore, the data comes in extracted. We have not even touched the event at this point. And so just be aware, those fields that you see here, they are a result of the being compliant with the protocol. Nothing here is produced process ID. Again, one of the design principles behind process ID, they want to know that Syslog, the Syslog source has different PID, and so you can tell if it was restarted. Well, the problem is everything you see here only makes sense if the vendor really utilize these functions. If they don't, then they're useless to you. If the vendor does not use the facility and the facility name and the severity, and if they don't use that data to communicate something to you, well, most of them don't, because all they care about is delivering what the product produces, then all the stuff becomes noise. And that's when we come in. We can just remove a lot of that stuff here and reduce the data quite a bit. Again, this is just an example of reduction. In other demos, we've seen not just reduction of data, we've seen enhancement and all the stuff. But in this particular case, I mean, there are fields that you can actually take off. You can you can add in. You can sample events if you wanted to. I don't want to go through the whole spiel of how do you do reduction and enrichment, because that's really not the main discussion here today. But just the main function, just the main thing to be aware of, that we can be 100% replacement for Syslog, either our Syslog or Syslog NG. We do a better job at it, and because we have a UI at it. And I remember when I managed Syslog, I had a bunch of COM files for Cisco, for the IDSs, and like all the stuff can be replaced with the pipelines and routes. So you have an easy to use UI to manipulate your Syslog events as they come in versus trying to do it through the COM files. Questions so far?
No questions so far that I'm seeing coming through. If you have any questions, please use the Q&A feature in Zoom to ask those. And just for a time check, we have about 10 minutes left, Mo, if there is anything else you wanted to walk through.
There's stuff to talk about, but I was just trying to avoid repeating the previous discussions for enrichment and enhancement. Yeah, I mean, I've seen, and realistically speaking, now when I say you can replace your syslogs, some people, what they do is they would actually utilize, once they become new customers, what they do is they take the old syslog hardware and they make it a LogStream nodes. That's one functionality. What would you notice right away is the resource utilization for us is way lower than other, because Syslog, the engine, the NG, Syslog NG or Syslog, they are IO bound. That's why, for example, Splunk does not recommend having an indexer and a Syslog in the same box, because they're both competing for IO and IOPS. So they tell you that's a no-no, it's a bad design. And again, it's not so much the regexing piece of Syslog that's really taken resources, it's actually the IO issue. We do not have that problem here. Okay, the only time IO becomes an issue for us is if you decide to use persistent queuing, meaning if the receiving end where we send the data failed, we're going to have a temporary storage. But then we're back to, again, being CPU and memory bound. And the CPU piece is because of a lot of regex and filtering and extraction and image and event manipulation. So just another thing to be aware of is when you replace us, if you decide to replace your old syslogs with worker nodes, you will really see massive enhancement in terms of performance for the similar functionality. Most people use their syslog upfronting, their repositories, login repositories, is just for, first, because Splunk and Elastic do not do syslog very well. They can receive it, but they don't do it very well. Second, it's maybe data queuing or a queuing mechanism. What happens if my Splunk is down? I want to be able to queue things. And we replace both, but the difference here is like a persistent queue. Persistent queue takes effect only if the receiving end is dead, meaning we'll become IO bound, or IOPS becomes an issue for us if your receiving end is dead. In the traditional syslog architecture, no. I'm sending everything to disk because that's what I'm designed for. I'm going to have a UF to pick it up there. So you constantly IO bound. You constantly need IOPS. So that's one of the major design differences between the way we implement syslog. We're just a router, a true data router. Traditional syslog is store and forward. That's the design intention behind it. That's trying to think of other things that, yeah, there are a bunch of articles out there if you guys are interested. This is a good article in our docs, and it talks about a specific use case. How would you parse events around syslog and what gain you can get from it? But again, this is just the other function of the product is really the ability to reduce data and process data. It's not really addressing the use case that I was talking about today. Is like just hardware replacement. That's really, for me, is there's a return IOI. This is measurable return IOI when I'm able to replace my servers and remove them out of the picture. By the way, it's not just syslog we can replace. If you have any if you have any heavy forwarders in the environment that do nothing but routing and they don't have any Splunk apps, we can also be a replacement for those. If you have heavy forwarders, Splunk heavy forwarders in the environment, and they have some apps, Splunk apps like DB Connect, depending on the app, we may or may not be able to replace it. So check with your SE on that one. For example, we cannot replace DB Connect, but we can replace Kafka Connect. We can replace Office 365 app from Splunk. So some apps can be replaced, some are not. So a point is, not only you have potential to reduce your syslog infrastructure, you also have potential to reduce your heavy forwarders infrastructure if it was separate than syslog. Okay.
Well, thank you so much, Mo. I don't see any questions coming through, so I think we can go ahead and end early. What I'm going to do is turn my video on so you can see me. What I'll do is I will send the recording of this out to everyone who's attended today, and then anyone who's registered but couldn't make it for whatever reason or had to drop off. And then I'll also include a link to our docs, that article that Mo is just screen sharing. If any other questions pop up, feel free to reply to that email, and I'll be happy to answer any additional questions that you guys might have. But thank you for joining, and I will see you next time.